All right, so for the lesson 8 video quiz, we have a voltage source with a resistor and a capacitor in parallel. So my strategy with this, I mean, I feel like it was really long and probably a really bad way to do it. But what I did was I thought that if I put both these elements in, just like combine them through parallel impedances, then I could get the current of the source. And then when I get the current of the source, I go back to the original circuit and apply current division because now I have the impedances of each element and the current source, or the source current, whatever. So I found the impedance for the resistor, which was 40,000. It's given because it's just whatever. And then the impedance of the capacitor is all these numbers. This is a lot of just random numbers, so I don't really want to keep spitting out 333.33, whatever. So I get that number for, I called the resistor Z1 and the capacitor Z2. So I get that number for Z2. So then I find the parallel equivalent. So I take 40,000 times that, divided by the sum of them, and then, so I get this, and then to take the J out of the denominator, I multiply by the, let's see here, I forget the word, that math was a long time ago, but I multiply by that, and I get these big numbers, and then I keep simplifying down, and I get my Z equivalent to be this right here. And I convert it to phasor by using the square and square root, and the imaginary divided by the real. So then my impedance equivalence is this 333.239 with a phase angle of negative 89.5224. So then to get the current source, I use the given voltage, which I had to convert, grab this 100 and throw right there and put this phase angle right there. So I divide. So then I divide 100 by 333.239, and then the phase angle is 20 minus the negative, so that's added onto it. So I got the current source to be 0.30085 with the phase angle of 109.522. So then I go back to the original circuit and I use current division, and to find the current of Z1, I put Z2 in the numerator, plug all these numbers in. I get this, just a lot of big numbers. So I multiply it through, and then let's see here. And then I just keep simplifying down to get this right here for IZ1, and then I convert that to phasor, so squares and square roots, and then the inverse tangent, and then I multiply the current source by this junk. So then I get the current going through, let's see here, the 40 kilo ohm resistor to be 0.0025 with phase angle of 20.0276. And the, let's see here, the frequency, what would that be? Angular frequency would be 60. So then I use the same process for IZ2. I put Z1 in the numerator because I want Z2. So plug all these big numbers in. I realized that this would be the same number from the last calculation. And I get this after I simplify. and take the squares, inverse tangents, and I get this right here, 0.999966 with a phase angle of 0.477. And then I multiply it out, so I get 0.29999 with a phase angle of 110 because you add both of these, and it's pretty much not, it's pretty close to 110. So I just said 110. So then that would make my current of through the capacitor that. So my final answers: 0.0025 with phase angle of 20.0276 through the resistor, and 0.29999 with a phase angle of 110 through the capacitor.